Hey, Peter.
Hey, Daniel, how's it going?
All good, all good. How about you?
Yeah, not too bad. Where are you at, Daniel?
I'm in Romania, actually.
Romania, nice. Okay, cool. So it's getting a little late for you.
Yeah, for us it's 8 p.m.
Okay, not too bad then.
Nah, it's not. It's not dangerous.
Cool. Well, awesome. Thanks for joining. I'm gonna give it another minute here to see if anyone else joins. And then we'll get started. Anything specific that you wanted to cover or add to the agenda today?
Peter, the only thing I wanted to discuss a bit is about the PR that we have open with the documentation for the OCI. I talked a bit with Stefan about it. Yeah, and I think Roy is joining also. So yeah, if we can discuss a bit about that PR and see how to progress with that, because it's been stuck there, and helpful documentation. I guess it's always nice to be immersed.
Cool. All right, sounds good. Hey, Roy, how's it going?
Sure. Great, guys. I'm going to shut my video off because I'm having some internet issues. CenturyLink is being great.
Cool. No worries. All right, let me share my screen here. All right, can you see that, Daniel?
Yeah.
Awesome.
Just a second, so I can give you a link for that. It's PR 4781. I'll put it in the chat.
Yeah, I mean, I'll work here, but I don't work here. Oh, okay, my bad.
Wait, oops, I get out of this.
That's a big zone.
Yeah, there we go. Oh, no, I've like screwed this up somehow now. Let me reset this.
That looks amazing.
I know, it looks terrible on my screen too. I've somehow caused the zoom in issue. So strange. Why does it keep resetting back to this? I don't want this. All right, I'm gonna stop sharing and close that and reopen it. Sorry.
No worries. Probably some kind of extension.
Probably. Okay. All right, and we're back. All right, so two new things in version 0.42. First one we have here is object.subset, which pretty simple. Basically just how it sounds. It detects if one object is a subset of another. And so we'll go over a quick example here. Threw together this Rego playground, showing what it does. So first object is going to be the superset. So if we go 1, 2, 3, and then second object is any part of the subsets 1 and 2. Oops, but it does need to be the same type. So actually comment everything else out. Otherwise we'll have an error. Right. So that for an array, for an object, we'll create another simple object. So 1, 2, and 3. And then the internal, what we're going to search for is just if 2 exists. Wait, that's something up. 1, 2, 3. Object 1, 2, 3.
Looks like you got a comma there after the colon at the very end of simple object.
There we go, I do. Yep. All right. Typo solved, and there we go. Last one is just set. So we can just have green, red, and blue. And then any sort of subset in here. So if we do green and blue. So that's how it works on a very simple scale. So let's make something a little more complicated. Try to take this object here, and we'll make a set inside of two sets. Then maybe we'll add, yeah, so inside of here, and then let's see, what else do we want? Maybe we can add another array in here as well. So then we can find a subset of that, say, right, if I expect two green and 3, yeah, say that 3 should be able to find this. Then we will make a test case here that says object looking with this is the superset and this is the subset. And then we'll just make another set with just something completely random in it. And we'll have that as a failed test case, showing that this not with the not keyword here will not equal true. And there's our subsets and our two test cases. So that is object.subset. Yeah, cool. Any questions from anyone?
Does the Peter, just
Yeah.
the type does it need to match, for example, in the subset? In the case of 2, you're searching for an object that contains the green. If you change the subset just to have the string, for example, would it match?
Oh, so the string not in an object. I don't know. Let's find out. Yeah. Okay. So I think it's just like an object mismatch here.
Yeah, it's yeah.
Yeah.
Okay. Thanks.
Cool. But good question. All right. And then we will minimize that one. And the next one we're going to look at here is the new keywords, contains and ifs. Go. So with these, so as with all new keywords, you do have to import the keywords. You can import all of the keywords with future.keywords, or you can do specific ones like .contains and .if. But for this, I'm just going to import everything. We're working with a little bit of input data here to kind of showcase this. I have an object with 2 lists in it. There's a food list, and then there's a fruits list. And so with that, we're going to look at the traditional way to create a set in Rego, which is with this format here, where you list what it's going to be called. You say what you want to be inside of it, and then you give the parameters. Right in here, we're saying when fruit equals fruit is going to be assigned any of the items in input.food, and then if that fruit is equal to something inside the fruit list, then it will be assigned. So here we can see apple and banana are in our fruits for our lunch. So now we're going to look at this with the new keywords. Right, so now we have lunch contains fruit, which is the same as this here. And then we use more keywords here when some fruit inside of input.food. and that just gives us the keyword of fruit assigned to any of these. And then that fruit is in input.fruits. So with our keywords here, we're able to see that we have the same output. And then the last piece of syntactic sugar here is the if keyword. So this and this are pretty much exactly the same, except now we have this if keyword at the very end here. And so this is just for readability. If you're sharing a policy with someone who's newer to Rego, you might add these if statements to make this a little bit more clear. So now we can see that we have the same object being created with these three different ways of specifying. And then let's just go over a couple more examples of if. So here, we're going to show using if to decide what time it is. So here at the bottom, I'm just calculating the time in Mountain Time, which I am in. Just grabbing time.now, and then we're saying, right, it is breakfast time if it's between 5 a.m. and 10 a.m. It's lunchtime if it's between 10 a.m. and 5 p.m. and dinner time between 5 p.m. and 11 p.m. Right, and so that just gives us, oh, sorry, that was partial. There we go. And so here we can see current time is 11, and so it is lunchtime. Yeah. So that is a very simple version of contains an if, and we hope that these keywords are going to help people make policies that are a little bit more clear for their readers. Any questions from anyone on the call? Cool. All right. With that, let's touch on the roadmap for 0.43. So what we have here, we have decision replays with JWT tokens. And so essentially it's not just JWT tokens, but it's just functions that return non-deterministic values. So here we can see a list of some of these. And so making sure that the decision log is going to contain the outputs for these functions, so that if someone does have to replay something, or if someone has to go back and look at the logs, it's a little more clear on what happened during that decision, having just a little bit more data there to go back and review. Oh, hey, Philip.
Oh, no, I was just going to comment that, yeah, our plan is to currently, we'll probably end up saving the outputs from a lot of these functions, like http.send, like we already cache the results. So we're already hanging on to this data in memory most of the time. So it's not a huge additional overhead to just go ahead and write it out. I think there are one or two spots where we don't do that yet, and so that's part of what these changes are going to end up rolling in. Yeah, I think the plan is for replay that we're going to try to do soft errors when no appropriate output exists in the records. So you could have HTTP send occur in multiple spots in your policy, right? And you might target different URLs. Depending on the order that evaluation occurred in when you ran the policy and generated the decision log, there might be a couple http.sends that never ran, right? And so this can be problematic when you want to do replay because, well, what do you do when you don't have anything there? And so if evaluation order ends up changing in the future, or if you're running under different settings and you end up evaluating something where we have a non-deterministic function and we didn't cache or save whatever its outputs were, I think we're just going to generate soft errors for that. At least that's the working plan. We'll see what shakes out during implementation. The main goal of this is ultimately to allow kind of diff testing between policies. So you make a policy change and you want to see like what was the result of this? Like how would the decision have changed if I changed this like one check in my policy? And so we're getting there. This is one of the last major holes in the boat that needs patching up before we can do that kind of replay and live testing. yeah, so that's some additional context around this change. And yeah, we're hoping we'll be able to roll that into version 43.
Cool.
Yeah.
Awesome. Thank you for that, Philip. Yeah. Any questions on that, or we'll move into the next couple performance features. Awesome. And so this one has already been completed, but did not make it into version 42. So this is ready to go out when version 43 launches. And so this is being able to handle objects with a large number of keys. And so here we can see the original PR, but let's look at, I think this was kind of more interesting when Philip had some benchmarks here. And so it's kind of showing with how it was working, the degradation here at 40 to 60% when we're over 50,000 keys. And then we're able to see it here, just how that maps out. And then Phil, do you want to run us through these just to get more detail?
Yeah. So the benchmarks tell some of the story, but not all of it. So the historical context is long ago, OPA had various ways it was managing the keys for objects, and at some point along the way, we needed to have the keys in sorted order deep inside the evaluator to ensure that we would always have like a consistent order that we went through all the keys and values in. And there were reasons for why this was done. Most of it had to do with unification working right and comparisons working the way they should. This also meant that like when you go to print out an object with string, you would get keys in the exact same order when you print them out every single time, which makes your tests easy to repro. At the surface level of the language, keys are still not guaranteed to be ordered, but internally, we do a fair bit of ordering. The change where the ordering thing was introduced was meant to solve a bug that was originally breaking Gatekeeper. It's a long saga, but ultimately what happened was we were doing insertion sort on every single new key that was added. You know, you're paying a log of n cost basically to do like a quick sort to see like, do we already have a key like this? And, you know, where should we stick the new key in? The problem is what was happening with that insertion sort was we were managing the keys in a Golang slice, and the slice was getting split in half and the new key inserted in the middle sometimes. And the Go runtime is incredibly good at hiding the overheads of that until you get past a certain size. And then it can no longer hide the overheads of the underlying memcopy and memmove operations. And you start having to pay the bill in full every single time you want to insert a new key. And so with this string Marshall JSON benchmark, this was one of two benchmarks I put together to try and demonstrate the change in asymptotic performance for object insertion. So this one just shows that performance degraded for small objects for stringifying them because the keys are not in sorted order and you have to pay the overhead of a quick sort operation, which for small objects, the sorting overhead is going to dominate. So as you get to larger and larger sizes, though, the sorting overhead gets amortized out. And the two scale about linearly with each other. If you scroll down, Peter, so that, can we get both benchmarks on the page? Yeah, you'll see that as you get up to larger and larger numbers, I think it's like, yeah, at 50,000, their performance is basically, if you squint at it, it's pretty close, right? But for objects under 50,000 keys, it's something. So let's scroll down to the object.insert benchmark. This was the one that changes dramatically. So what was happening in the original motivating test case for this was a customer of Styra tried to put a 1.2 million key JSON document into OPA to work with it and do processing on it for some reasonable purpose, right? But they sat there for multiple minutes waiting for the document to load, and were deeply confused as to why that was. And it turned out that object.insert was on the hot path because of, as I mentioned earlier, you split Golang slices apart. Once you get up past a certain number of keys, the Go runtime can't hide the overheads anymore, and you have to reallocate the whole slice, copy over everything, copy over the new item you want to insert, and then everything else. And you start paying those overheads really, really painfully in the range of, when I played around in the benchmarks, it was like 120,000 keys up to about 140,000 was where performance started to go exponentially bad. You started paying massive overheads for that. I don't know if I put the profiling graphs in this thread.
Don't know that I saw them.
No, I didn't put them in here. Darn. I can actually screen share the profiling graphs in a minute if that's something that you want to see.
You have them available.
I do. I can pull those up. But the benchmarks kind of tell the tale here. At 138,000 keys, you can see that there's suddenly a massive drop in performance for just constructing an object incrementally with object.insert for every single key. And then for the new way that this PR rolls in, performance scales basically linearly. So let me see if I can actually pull up the graphs, because that was a fun one.
Yeah, stories are easy to hear when you have a nice picture.
Yeah. Let's see. Ah, there it was.
Stop my share here, and you should have the ability to share.
Awesome. Alrighty, give me 1 second. Yeah, let me share screen here. All right, can you see the graph? Can y'all hear me?
Oh, sorry. Yeah, I was talking to myself.
So this is the profiling graph for the main branch, if it's screen sharing correctly, and you can see that when you're running the profiler on the test suite, once you hit the top of the benchmark, you'll notice this is for the 138,000 key example that was shown in the benchmark. You can notice that the whole hot path here is dominated by runtime memmove, which this is when the Go runtime can no longer hide the overhead of splitting a slice in the middle. With the result of the PR, we append only onto the end of the slice and then do sorting later when we need to, and only when we need to. So you'll notice that this graph is much more diffuse in color, and you'll also notice that the top of the profiling graph is 1/4 the time shown for this graph, 62 seconds versus 14 seconds for like 4 times the keys inserted. So let me zoom out a little bit. So basically for this PR, we just changed the asymptotics of object construction. So for very small objects, there will be a tiny bit more overhead. And for very large objects, well, at least you can do them now. They'll scale linearly as they get bigger. If this change winds up being a performance win in the wild, we may port this same technique over for sets. And there are a few other things that can also improve the runtime of this even further. I'm thinking of changing the sorting algorithm in particular, as that might allow us to get a small performance win back for small objects. Yeah.
Awesome. This looks
Any
good.
questions? Any questions before I stop the share?
Cool. Right. Awesome. Thanks for that, Philip. I'll take this back over. And browsing. browse it, and let's see here. I don't know, 2 more things on the list here. Another performance improvement here. Basically, improving the indexer to support multiple expressions. So right now it's very limited on the types of rules and expressions that it will index on, so that it can have those just readily available. And so with this improvement, we're going to be able to see newer types of expressions be indexed and cause performance improvements to be when we're loading rules and when we're able to evaluate them. And then, let's see here. The last one here is built-in function. We don't have a ticket open for this one yet, I think, but creating a new built-in for PGP signatures. Awesome. And so with that, does anyone have any questions on the roadmap for 0.43? All right, then let's check out this PR from Daniel. So what's going on here? And so Daniel, what was your question around this PR?
Yeah, so my question around this PR is there's been a lot of discussion on this PR and between Omri and Stefan towards the end. My question was that the tool that we're referring in the documentation here is one of the tools that we built, the policy CLI. That tool basically allows you to build policy containers. The idea is, at the moment, as it is, everything's open source and it's pointing towards that open policy container registry. However, this tool can be used with basically any OCI spec compatible registry. So you could basically use it with GitHub Container Registry, GCR, Azure, whatever, down the line. My question is, this tool will definitely be very useful for the entire OPA ecosystem, I guess. Is there a possibility we can take advantage of this tool somehow to improve the experience when you're building containers with policies?
I think it kind of depends on what people are using the containers for and kind of what model they want to run under. I've definitely talked to a few users that they already have a solution for hosting bundles themselves, and they build their own internal builds of OPA, sometimes with additional built-in functions. And so for them, I would have to look a bit more at the policy tool to understand kind of where it would fit into the experience for those folks. So I'll admit I'm not particularly familiar with OCI registries in particular, and I haven't actually looked at this thread because that's a little out of my wheelhouse. But yeah, I suppose I'll cut out some time this afternoon to take a look at it and see if there's anything that can be nudged along here.
So can I ask a question about this?
Sure, Jimmy, go ahead.
The purpose of this OCI compatible registry functionality is that you would not have to use bundles, and then you would just deliver policies as containers into, let's say, like a Kubernetes cluster. Is that what the purpose of this is?
Yeah, basically you could use containers as instead of the tarball.
Okay.
That's the idea behind it.
I think it's very interesting. You know, for me at least, it's very interesting. I mean, I've been working with OPA since 2018, and bundles have always been a challenge for us. I think the DAS tool is amazing, and how it makes it so easy to deliver bundles and update bundles. You know, but this particular tool here is very interesting to me because I know other folks are challenged with, like you said before, Philip, hosting their own bundle server. So I think this is, for me at least, I saw this a couple of days ago. My boss pointed it out to me, so I'm very interested in it as well. So I'm gonna take a look at it as well.
Yeah. I do think I should probably take a look at this on account of this is. I certainly think like OPA is primarily deployed most heavily in the Kubernetes ecosystem, so I probably should spend a little bit of time at least taking a look at this because this looks closely related to the core mission of the project. So, yeah.
Yeah, I like the fact that it's underpinned by OCI standards. So it should, outside of any unknown issues, the adoption should be fairly easy because of all the other OCI standards out there. So you just start using it. But yeah, I'm very interested in this. I'll take a look at it as well.
Cool. Thanks, Jimmy, and thanks, Daniel, for bringing this up. Okay, we are at time here. Is there any last minute questions that people want to ask before we shut down the meeting? Awesome. Well, thank you everyone for your time. Thanks for listening in, and I will see you all after the next release. Cool. Bye, everyone.
Cool. Thank you.
Take care.